Okay, let's talk about the three-dot problems in Chapter 4. So there's one on each assignment. On the first assignment, we have lovely number 53, which is, again, bar none, one of my favorite problems, like in the book. So in this figure, which I've reproduced here, a baseball is hit at height h equals 1 meter and then caught at the same height. It travels alongside a wall, moving up past the top of the wall 1 second after it is hit, and then down past the top of the wall 4 seconds later, which we've indicated as t equals 5 seconds. At a distance d, 50 meters a lot further along the wall. So A, what horizontal distance is traveled by the ball from hit to catch? What are B, the magnitude, and C, angle relative to the horizontal, the ball's velocity just after being hit? And my favorite, D, how high is the wall? Which just kind of seems like a ridiculous question to ask in this scenario. But the trick is, if we look at it, the whole problem really begins to unravel as we look at what's going on in this 4-second window where we're flying this distance d. So this is our starting point. If we can figure out what's going on there, and that's going to feed into A, then we can slowly begin to unravel everything else. The other things to notice is that projectile motion is very symmetric. So if it took 1 second to go from H to the wall on this end, guess how long it's going to take on this end. Hint, also a second. Anyway, that's, I think, enough to kind of get started there. This problem, if you do it in order, it works out very well. Then that brings us to the other problem, number 67, which I have playfully tried to illustrate here. So in 67, a boy whirls a stone in a horizontal circle of radius 1.5 meters and at height 2 meters above level ground. So that's what we're seeing here. Here is our circle. This is a bird's eye view. And here is, side view, where we see circle going around the head and 2 meters above the ground. Never mind that 2 meters, 1.5 meters appear to be equal. The string breaks and the stone flies off horizontally. So that's what we got going on here. This is, again, bird's eye. So it breaks just like it had been going here, and it just starts going in the direction it's going. This will make sense when we talk about it in class. And if you're reading it after we talked about it in class, then this should totally make sense. There should be no question about this whatsoever. Now, it hits the ground at a distance 10 meters away. And so the question is, what is the magnitude of the centripetal acceleration of the stone during the circular motion? Which is basically asking, what's V? And so, more or less, we need to solve then this projectile motion problem. You'll notice the trick with these three-dot problems is they tend to have kind of two problems glued together. So this is a projectile motion problem stuck to a centripetal motion problem. And this is, quite frankly, just a really crazy projectile motion problem and like a logic thing. But hopefully it's enough to get you started. And yeah, have fun.